Hello and welcome to my video on work and angled force. So to start with, this is the introduction to the energy unit in Physics 20, and the energy unit is probably the most covered unit in Science 10. The topics are covered, especially conservation of energy and work, and so some of this should be familiar for you. If not, please review a little bit of Science 10. So anyways, work is a change in energy. It's a concept telling us how much energy was inputted into a system from transfer of energy. So energy cannot be created or destroyed, which we'll talk about later, but this is just an input of energy into the system. So work equals change in energy. Okay? Also, work is force times distance. Okay, but the big thing here, this year, is that it is times by cos theta. So why cos theta? Well, because our force applied has two components to it. We've got the green part, which is our vertical part. And we've got the horizontal part, which is this red part here. And so our force applied actually only, when we're talking about calculating our work, it only takes into account the portion, the component of the vector that is in the same direction as the direction of motion. So they have to be going in the same direction for them to count, which is why we use cos theta in order to find this red side. So it's force cos theta. And so that would get us the value of the red side. Okay, and to note about that, if the angle is 0, cos theta is 1. Therefore, that term disappears. 1 times anything is still what it was before. And also, interestingly, if theta equals 90, sorry about that. Okay, if theta equals 90 degrees, then cos theta equals 0, and that would tell us that work equals 0. i.e., that means that if the force is not in the same direction, if it is vertical compared to the direction of displacement or direction of motion, then none of it counts towards the work, because it has to have some component going in the same direction. Okay, what else is interesting about this? Well, we know work is change in energy. We know that would be joules, because energy is measured in joules. But we also know work is force times distance. Well, force is measured in newtons. Distance or displacement is measured in meters, so it's a Newton meter. So oftentimes you might hear about Newton meters. What else is it? Well, a Newton, we can say, is kilogram meters per second squared. Right? And so if that's the case, Newton times a meter would be kilogram meters squared per second squared. So a joule is actually still, everything is measured in SI units. Kilograms, meters, and seconds. Okay? And so so far, we haven't looked at some of the other ones, like Kelvin, but kilograms, meters, and seconds. Okay, let's continue here. So the graph of the force versus displacement. Well, force and displacement, if you think about work equals force times displacement, if you just multiply force and displacement, then you get your area under the line, and you get the work. So if you find the area under the curve or under the line, that would be your work. All right, let's take a look at a few examples here. So to start, here's a nice easy one. A student rides a bike home from school with an average force of 50 newtons over a 4.2 kilometer bike ride. How much work was done? Well, simply work equals force times distance. So the force was 50 newtons. The displacement was 4,200 meters. And so what we have to do is multiply those values together. So if we do that in my calculator, I get 210,000 joules, which we might write as 210 kilojoules. Or in this case, because we've got 2 sig digs, we would need to write it like this. 2.1 times 10 to the 5 joules. And that would be our final answer. All right, let's take a look at another one. A student carries some textbooks, pushing upwards on the textbooks, and carries it a distance of 150 meters. Well, if they're pushing upwards and they're carrying it horizontally, then the direction of force is actually in a completely different direction from the direction of movement. Since that is a 90-degree angle, cos of 90 equals 0, and therefore the work done is 0. So 0 joules of work is done because their direction of force is in a different direction from the displacement. Perhaps you could say they lifted it a meter up in the air, in which case you could talk about the vertical work done. But this distance here has nothing to do with the vertical. That is a horizontal displacement, and therefore the force and the distance are different. All right, let's take a look at our last example here. Mr. Drager is pulling his kids in a wagon with a total mass of 26.3 kilograms, so 26.3 kilograms. Here's my beautiful wagon. He's pulling with the force of 75 newtons, and the handle's at an angle to the ground of 40 degrees. So I'm pulling with the force of 75 newtons, and we've got that degree. And if we know that the work done is 11.4 kilojoules, then what we can do here is try to solve for the displacement. So work equals force times distance times cos theta. Well, we're looking for the displacement, so let's move things around by dividing by f cos theta on both sides. Let's actually show this. F cos theta, f cos theta. So we're left with w over f cos theta equals d. So if we go ahead and plug all of these values in, let's just keep in mind that this is in kilojoules, so it actually needs to be converted to joules first. And then we have 75 newtons, and then we have cos 40 degrees. Okay, so let's go ahead and plug this in our calculator. Which gives us 198.42 meters. And so that would, with 2 sig digs, which is what we have, that'd be 2.0 times 10 to the 2 meters. So 200 meters, but it equals this. So that would be our displacement. Right, and so we just solved a couple versions of this, but keep in mind that you could have to solve for your work. You could have to solve for your change in energy. Whoops, that was weird. You could have to solve for the change in energy, could have to solve for the force, could have to solve for the displacement or the angle. You could have to solve for any part of those, and you should be able to solve them. All right, I hope this video helps you better understand work and angled force. And make sure you take a look at the next video. Good luck!